This is going to be a continuation of Chapter 10 or Chapter 9, whatever book you're reading. It's about subnetting. Okay? We left off, we were talking about some different techniques. Now we're going to get into the nitty-gritty of it. The end of the chapter has some good questions. You will have some similar to that on your test. Okay?
Chapter 5?
Not 10 in your book. Chapter 10.
Never mind, I just forgot what chapter we were on.
Yeah. At the end of the chapter 10, there's some good questions. I recommend going through them because you'll have some similar questions on the test. I actually met with a student for an hour this morning from a different networking class, and I helped him go through all the questions because the book explains it, but it's a little hard to understand sometimes. I think I explain it a lot better. So you're lucky. And also, my recordings from last year are up there. I already told you all that, I think. Didn't I tell you all that? My recordings from last year, if you go to WordPress, wordpress.rose.edu, you can see all my recordings from last year. So you can actually see the whole rest of the book almost already. But know how to do it. So we're going to talk about some of this, okay? So some important things about subnetting are, actually one of the questions at the end of the chapter actually wasn't a question. It was a student had a question. It wasn't a question in the book, but she's like, it says in the book, and I also say in my recordings, that subnetting provides security. Okay? Everybody know what the HIPAA law is? What HIPAA is? It's some freaking medical stupid thing that drives me crazy. Basically privacy. Okay? Whole point of it is privacy of medical information. Okay? Well, with that law in place, can they just take you on a big old group to thousands of people and start discussing your medical records? No, they have to keep it separate. Networking is the same way. How much privacy would we have if we just had one big, huge classroom with all the classes in it? We'd have none. Because everybody would be talking over each other and you couldn't hear anything. But subnetting allows you to break your network into smaller pieces. Okay? Because like right now, I can tell you guys something and Shalon's class can't hear. Because we could be subnetted apart from them. Okay? So subnetting breaks it into pieces. Okay? So, and you get more security by breaking into smaller networks. Okay? Like at our houses, we all have routers, I'm assuming. Most of us, at least. And your routers, actually, let me see if I can get one up here real quick. No guarantees here. I'm not sure if this one comes up or not. Maybe. Yeah, okay. This is a Linksys router. Okay? WRT whatever, 54G, I think. Yeah, WRT54G. I'm assuming some of you have something similar at your house. Okay? Now, you'll see in here, you have a subnet mask provided by your ISP. You have a subnet mask for your local network. This is what your machine's internal all get. So at your house, if you connect your laptop, your iPhone, whatever, they're going to get an IP address starting with that as a Class C. So this is the Class C. I can tell that because it's 255.255.255.0. Everybody with me? I can actually zoom in a little bit so you can see it better there. Okay? Now this one's actually disabled, but pretending it was enabled. So this is when I'm doing it a different way. But at your house, you probably have this enabled. That means you can give it an IP address. It's in this range, so it's going to be 2, 3, 4, 5, 6, whatever. And you're going to have a Class C subnet mask. Now, I can click that drop-down box, and I have varied options. Okay? Has anyone ever changed theirs at home? No. No one changes it. Well, so the default is that top one there. Okay? 255.255.255.0. How many computers can we have on the network? Anybody know? It's 256, but really we have 254 usable. Okay? The way you tell that is, so if I took, where's my notepad? If I did 255.255.255.0, that's the subnet mask. I'm only going to worry about the ending part, the 0. Okay? So if I went 0, does anyone know what 0 is in binary? 0. That's it. basically. I mean 1 or 8 zeros, but doesn't matter. But there's 8 zeros. An octet, the 255 is an octet. Let me zoom out. You can't see it. It's kind of handy. Okay, the 255 is an octet. The second, there's 4 octets. It's called an octet because 8 is oct in Germany, an octet. So that 0 is actually 8. I'm only focusing on the end. Okay. Now, the way you figure out how many is available, it's since we're working in binary, it's 2 to the number of zeros. How many zeros are there again?
8.
Okay, so 2 to the 8th is 256. If you're not sure how to do that, put your calculator out and go use scientific 2 to the 8th. What's this? So we have 8 zeros. Zeros always mean the number of hosts. Okay. Now the way this is really written out is actually this. Come on. So if I was to convert the entire subnet mask into binary, that's what it would look like. The whole thing is now in binary. The 1s are the network ID. The 0s are the host ID. Everybody with me? Or the host, yeah, host ID. So if I go back to that website, with this subnet mask, what's the network ID? 192.168.1. That's the network, okay? And the host is number 1. So this machine's address, this router's address is 1. It's going to give out 2, 3, 4, 5. It'll give out whatever, okay? It's actually disabled, but it could, okay? If I enable it right here, it would. I give them out from a server is why this one's turned off. But they always give them out in this range, okay? So with 8 zeros, we saw that with 8 zeros, it's 2 to the 8th, which is 256. So 256 computers. You can't use the first and the last. And if you read the book, the formula is 2 to the n, that's raised to the n, 2 to the n, minus 2, since I can't write exponents on this text pad. But 2 to the n minus 2. So 2 to the n was 256. Minus 2 is 254. That's the number of usable addresses. Now, no one listened to the recording I did last year on this, did they? Tracy reminded of. Did I ever tell you about when I used to give out IP addresses at the ISP downtown? Well, we sold DSL. A guy owned it, and he basically sold it to his girlfriend. And she knew about as much about networking as this remote control. She knew nothing. And they needed someone, so they hired me. And that was kind of a weird deal, but they hired me to do everything. They basically said, oh, by the way, Kim, we want to hire you, and you're hired right now. Come on in. So they hired me, and we sold DSL. Okay? Well, I just told you that with 8 zeros, we can have how many usable computers?
254.
254, because we can't use the first and can't use the last. Okay? Well, we're going to look at all the different ones. So what if we had 2 to the 7th? Okay, so what if we did 2 to the 8th? We know that was 254, you said? Is that correct? So what would 2 to the 7th be?
28.
Okay. Is it 128?
126.
126 maybe?
Oh, that's right, minus 2.
Okay. At 126. Then what's 2 to the 6th? What's 2 to the 6th? Anybody?
62.
How is he figuring that out so easily? It's divided in half. It's divisible by 2. Take the 256, divide it in half. 128. Subtract 2. 128 divided in half is 64. Subtract 2. I mean, it's... Actually, you can subtract 2 from there. So the next one is what? So if I go down with 5, what do we get? Is it 30? Is it 30?
Yeah.
2 to the 5th.
32.
It's 32 minus 2. Okay. So let's go to 4. 4 is what? 2 to the 4th is 16, isn't it? Okay. Subtract 2 is 14. So we're talking about the number of zeros. So what I mean by this is 1, 2, 3, 4, 5, 6, 7, 8. This one is 1, 2, 3, 4, 5, 6, 7. Oops. Okay. What I'm doing is I'm making the possible combinations of these numbers. You notice that? And the thing about a subnet, the ones have to be contiguous. What does contiguous mean? It means all together. See how this host ID is all ones? Can I have a random 0 in the middle of it? No. Won't work. Because where the ones stop is where the host stops. Okay? So let's continue on with a couple more here. So 2 to the third gives us what? How do you get 6 out of that?
2 to the third is 8.
2 to the third. Oops, I wrote the number wrong, didn't I? 2 to the third is 8. So that means 2 times 2 times 2. So 2 times 2 is 4 times 2 is 8. Everybody with me? I'm trying to do it on the screen so everybody can see in the recording. So we got 2 to the 2. 2 times 2 is what?
So 2.
Okay. 2 times 2 is 4. But we can't use 2, so we only get 2. Okay. Then we got 2 to the 1. 2 to the 1 is 2.
0 hosts.
What the hell is that all about?
Use that for routers.
Yeah, you can use it for router. And you can also have 255. You can also have all one. When people used to come to me, and if they needed one address, their subnet mask was 255, 255, 255, 255. It's weird. It doesn't quite work with the formula. So you're really not going to work with the last ones. Okay? Now, what is... Now these are the number of available hosts. Okay? So, when I worked at that ISP, we sold IP addresses for DSL. You could buy 1, you could buy 8, you could buy 16, so on and so forth. Okay? As soon as they hired me, they're like, okay, yeah, we sell DSL, yeah, we got to give out these addresses. Like, people can buy 1, they can buy 8. I'm like, what? You can't buy 8. Because if this is the number of usable hosts, is 8 on that list? No, because 2 to the third is 8, but you got to subtract 2. Let's talk about this whole subtract 2 thing. With every network, you need what's called a network ID. It's like tree line drive. You know, I live at 8412 Tree Line Drive. 8412 is my house on Tree Line Drive. With a network, you got a network ID and a host ID. You got a host on a specific network. Okay? The network ID is the network. I mean, you have to be able to identify the network. Then you're a certain host on the network. So the first number is the network ID. So if you sent mail to me, addressed just to Tree Line Drive, with no name on it, just Tree Line Drive, who would get it? No one. Or any, just wouldn't go. They're like, huh? Who do we give it to? Now the last digit is what's called the broadcast. Remember when we looked at Wireshark a few weeks ago? There was packets just going everywhere without us doing anything. Those are broadcasts. They basically said we're going to send them out to everybody. You ever get mail that, like, what drives me crazy now is the buyer's guide? You want to get it beside me? I mean, it's like twice a week I'm getting it now. I never open it. It just sits at the end of the street for a while.
Then you gather up 3 or 4 at a time.
And then throw it in the trash. So what I try to do is, so I always get it like twice. I try to make sure on trash days I throw it in there, but it doesn't always make it in there. But the buyer's guide, does that go to a specific house? No, it goes to everybody. It's also like the Oklahoma. Everyone get the paper right now? No one gets the paper? Well, I used to get it, and the way you get the paper for a long period of time for free, you sign up for like 3 months or 6 months. That's it. Go online, sign up for a short period of time, maybe 3 or 6 months, and that's it. Don't pay them anymore. They're going to send you a bill. Don't pay it because you didn't subscribe for it. They're going to keep delivering it for about a full another year. Then they're going to send you, this is your final notice. We're going to stop delivering. I'm like, good. So that's how you can get it for free. But you can see there's no 8. Because if I gave them this subnet mask, right there, the one with 3 zeros, So 2 to the third is 8. So that ladies, right there, 8. We can. I said, yeah, but they can't use 8. They can only use 6. So it's kind of like, can you imagine buying a car? This car holds 5. Yeah, but one's the spare tire and one's the jack, so really you can only put 3 people in. I mean, that would suck. So you can't sell a network saying you can have 8 and you can only use 6. I only worked for them. They didn't understand. So I said, you know what? You're the boss. I'm just going to do whatever you say. And one day some dude calls me up. He goes, I got a problem. He goes, I bought 8 addresses from you. Yeah? So I only got 6. I said, yep. But I'm paying for 8. So I gave him 14. I said, here, have a bunch extra. I don't care. I didn't even update his billing or nothing. Because we were lying to the people. We weren't giving them 8. We were giving them 6. So that's one thing you got to watch. When I had my ISP at home, I had 120 addresses. Couldn't use the first, couldn't use the last. But I knew about it. So if you don't understand this stuff, you'll be like, what the heck? All right, so let's go back to the top one for a second. Remember the top one where it was all zeros? That was the address that was on that router we looked at. That's what most of you have at your house, the Linksys Router. So how many computers can you have on that network? Usable computers. 254. How many of you got 254 computers at your house? So why the heck are we using that for a subnet mask? Because that's what it said it to. But is that always the best option? The problem is that's what they come and no one ever changes them. Okay? So say you do have a bunch of stuff like me. Maybe you got a thermostat and a couple computers. Still, maybe you only need 60 or 30 or something like that. So you can actually change that. You could go into that router, right here.
Well, would you need to convert that binary number back to?
Yes, yes you would. We're going to see how to do that in a second. Yes. Because you would have to select the right one. Because this router doesn't give me the option for binary. Okay? But, everyone leaves it at 255, 255, 255, 0. So what does that really mean for us? Maybe someone breaks into my network. I forget to secure my wireless. It means 254 people can connect to my network. It's going to suck at that point. It's going to be so slow, but they could. Okay? At that point, we're going to run out of addresses. Also means anytime you're trying to talk to another device in your network, our networks are so quick now, you're not going to notice it. But it's going to slow it down by milliseconds. Because, it's like, instead of just talking to you guys in this room, I'm going to have to talk to 3 other rooms as well. Why do you need to do that? I mean, why, like when we put classes here, we try to get the right, like 221 can hold 30-something students. Did I really need that for this class? No. So we try to get the right size room for the right number of people. That's what you should do for your network. But you got a good point. You need to convert these back. So what is that in decimal? Okay? Anyone know?
The all zeros?
Yes.
0.
0. Okay, that was a tough one. What is 1 in all zeros? Remember that chart I drew last time? 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4?
128.
It's 128. What's the next one? 64. Just cut them in half. Oh, shit. No, it's not. Hold on. My fault. No, it's wrong. Sorry, I was screwing up.
Yeah.
But you got
I was going backwards. Sorry, I was doing it.
2 to the 7
All right.
and 2 to the
And
8.
if you go up here, you could actually, it was 1, it was 0, then, actually, let's just do that. It was 1, then it was 2, then it was 4, then it was 8, then it was 16, 32, oops, 64, 128. That was it, wasn't it? 1, 2, 3, 4, 5, 6, 7, 8. Now that was that numbers, 2 to the, starting from the left, 2 to the 8, 2 to the 7, 2 to the 6, 2 to the 5. So basically, with this one here, with 1, it was just 128. This one here with 2, it was 128 plus 64. Because we have a 1 at the 128 position and a 1 at the 64 position. This one has a 1 at the 128, 1 at the 64, 1 at the 32. So what do we get? 224? 240? 48, 252. And if we went, basically the last one you can get is 255, which is all ones. Okay? Those are the valid subnets. Can you have any other number? Is there any other combinations of ones and zeros you could possibly make out of this list? Making them all contiguous now. You can't have any spaces in them. There's no other way you could possibly do it, because that has none of them. That has 1, then 2, then 3, then 4, then 5, then 6, then 7.
The other octets.
Right, I mean, all in this one octet. Even if we go to the other octet, even if we go to here, then these numbers will be at this position. So if you can never ever enter a subnet mask other than that. Let me show you. You can try this if you want. I'll show you. I'm just going to go to control panel networking like we did last time. Remember we went to control panel networking? Yeah, go to control panel networking, then change adapter settings. And then I'm going to go to properties of my local network, TCP/IP4. I'm going to put in an address here. 10.10.65.65, just whatever. I can put in a subnet mask. Automatically put in that subnet mask. Anyone know why? I just picked a number. I'm not going to save it, so you can put whatever you feel like in there.
Does it generate it from the IP?
It does. It looked at that and said, oh, that's a 10 number. That's a Class A network. Automatically puts it in there. But I don't want that. I want to do it myself. So I'm going to put a 255 here. And let's go with a 255 here. And let's pick one off our chart. Let's pick a 240. Let's see if a 240 will work. Work. Okay, well, let's put a different one. I want this as my subnet mask. 241. Think that'll work?
Sure.
It won't, because they're not contiguous. So if I try to put in 241, hold on. You have entered, I thought it popped up right away, but you gotta wait till you say okay. You have entered an invalid subnet mask. Mask should be contiguous. Listen, just like I said. So they kind of make it so you can't screw it up. But I thought maybe it's the router that does that. One of them pops up the moment you enter it. Wasn't the IP address popped up the moment we tried to put an invalid IP address last time? Okay. So there has to be a contiguous number. So you can't have that. So I'm not going to save this. Okay. So 241 would not work because they're not contiguous. Okay. So what did we learn here? First of all, we learned based on the number of zeros, we can determine how many available hosts there are on our network. Okay? And we can determine what the subnet mask would be. So what we're talking about here is if I told you, okay, I want you to give me a network that holds 28 computers. What subnet mask would you use?
28.
28 computers.
Do 224
224? How do you get that?
based on the available number of hosts available.
The number of hosts available. Remember, it's really 32. 2 to the 5th is 32, but you can't use the first, can't use the last, so you get 30. 28 fits in there perfectly. So for that, our subnet mask would be 255.255.255.224. So if I went to my router and said, you know, maybe in my network I'm going to have about 60, well, I got 100 computers on my network, because this is for St. Philip area. Maybe they have 100. So rather than this one, I can actually set it to 128. And if we look at that list, you notice those numbers. I know it's hard to see, but those are the same numbers we had. They're all contiguous ones. Okay. So what do we gain by doing that? Well, our network will be teeny tiny bit faster. But what's going to happen? I mean, I've had people who heard me lecture over this, go home, change their router, whole network dies. Anyone know why it dies? Well, because once you save the router, then everything else on the network has to get a new address, because the subnet mask just changed. So that means every device has to release and renew, which means it could take a while before everything gets an IP. Remember we talked about the least duration for DHCP? If you got your set to 8 days, and you got something that doesn't reboot all the time, like my thermostat, if that's set to an 8-day lease duration, it ain't going to try to get a new address for 4 days. It means for the next 4 days, it's going to have an invalid address. It's going to have a different subnet mask or a different zip code, basically. Yes.
Change here in the command line, type IP, config, renew.
Yes. But what if you don't have anything to... Like, my thermostat doesn't have that option.
True.
See, I have a thermostat, I have a TED, I have my solar system.
But don't they have a user interface where you can...
Yes, I could.
Oh,
But what you would have to do, you'd have to be proactive. Don't change the router first. I mean, you'd have to go into all your devices, change those to what you're going to be setting it to, then change your router, and then you'd be fine. But if you're anyone like me, you're like, oh yeah, I got everything. But then you forgot one thing, like, darn it, the DVD player was turned off when I did it, or something like that, or, and then 2 months from now, you turn around, like, why ain't the darn thing working? Oh, that one's got a static address in it, or something. It's, so it can be tough. But it's a good idea to lower it. Like, for my house, 192 would be a good mask, because 192 is good because it gives you about 62 computers. It might sound like a lot, but, when I get all my cameras and everything else, I have a good 20 some odd devices. Now, if I'm already in 20 some odd, which means I'm right here already, I'm getting close.
so I
Once.
need to add some extra cameras in.
Exactly. And, when I took the certification test, I was actually talking to someone down in my office about this. In my opinion, out of all the certification tests I've ever taken, this was the easiest.
Network.
Yes, Network Plus. Was because I've worked with it so long. And they would ask you questions like they'd give you a subnet mask of 241. Your computer's configured with this IP address with a submask of 241. Why wouldn't it work? It's a bad address. You can't have it. So what I did is I wrote this across the top. Then you can write these down, and you know what they are. And I'm assuming most of you have never taken a certification test before. You have? They basically give you something to write on, normally a laminate sheet and a Sharpie or something, Visivus marker. And then, test starts at 2. That doesn't mean you have to start the test at 2. It means that what they I drive them crazy. It's like, all right, they put you in there, and I hit start. I'm like, give me a minute. I start writing down everything I can possibly think of on the topic. I've had it come in, sir, you got to start the test. No, I don't. I don't have to start the test until I'm ready.
An hour or 2 hours.
Yeah. So I just sit there and I write it all down. That way when I go back, because I basically write out this chart. Not all of it, but a lot of it. Because that way you do in the test, you're like, oh crap, what was those numbers again? Well, you can very easily calculate them based on this information. So, pretty handy to do. All right. So, with a Class C, well, actually, let's change it. Now, I like this one here, this 240. We're going to focus on the 240, okay? Okay, that's the one we're going to be using. Okay, that's the subnet mask we're going to be using. I'm going to put it up here. We're going to have 240. And I'm going to put this right here. Okay, there. I just redid my network as a 240. Everybody with me? Okay. How many hosts can be on my network?
240. 14.
14 hosts. Okay. Now the trick question. How many different networks can we have? How many different networks can we have?
16.
Actually, if you think about it, it's really 24 plus 4. It's really 28, 2 to the 28th, which is 16 million times 2, then times 2, then times 2. It's actually a whole bunch. Okay. But really the number of ones is the number of networks. But some places you'll read it and they'll say, well, how many subnets can you have with this subnet mask? And they'll say, you can have 2 to the 4th, which is 16. And there's actually a question book that's how they talk about it. Actually, let me see your book. You got it open. Question. It's kind of misleading the way they talk about it. Come on, where are you at? It's no, it's here somewhere. Cause I helped. Okay, it's question number 9. There. It basically says your computer has at least a Class C network address whose network ID is whatever they have there. You want to create 16 subnets within this network. Okay? So what they're saying is you already got a class C. That's this part. You know, this, where did the IP address go? I never wrote it down. Okay. But that's the class C. Then they're talking about subnetting the portion of it. Okay? Subnetting means you take your regular class full address and break it into pieces. You're taking your large room and dividing it up into rooms. Okay? And whenever I built a house, it was not a fun experience. I don't know about you guys. But when I looked at the plans for my house, they had this kitchen, dining area, then a living room, and then a formal dining area. My heck no, I had them wall that off and make that into an office. So I subdivided or subnetted my house so I have another room out of it. So I didn't have to use a bedroom. Well, same way we're subdividing our network, our Class C network, we're subnetting those 256 computers into smaller groups. Okay? So when the question talks about you want 16 separate networks, you're only going to look at this.
On each one of those separate networks, can you have 254 devices?
No. On each of these networks, you can have 14 hosts.
Oh, because that's the number we're using. Okay.
Right. Remember, the zeros are the hosts, ones are the network. So, with a Class C network, with this subnet mask right here, you have 4 ones in the 4th octet, 4 zeros, so we have 16 subnets, 14 hosts, because we should have 16, but remember, can't use first, can't use last. Okay?
So
Now.
you have 16 times 14 hosts.
What?
If you have 16 networks and 14 on each, that you could have a whole bunch of machines.
Right, but that's a good question. Okay, where is calculator? Let's do 16 times 14. Whoa. If we had 16 networks with 14 hosts on each,
That's a total of 220.
224, but I had 254 originally. Remember when it was all zeros? It was 256 minus 2, so we got 254? I just got gypped by 30 addresses. What the heck? Is everyone happy with that? But think of it like, okay, we're building something. That's the space for the walls and the doors and the foundations. And you're going to lose some because you got a network ID for each. You got a broadcast for each. They're all separate. So think of the cost of doing business. The cost of separating your network out, the cost of making it a little more secure is a couple addresses. Okay? Everyone with me? Okay. Now, isn't it nice? We're still on one slide and we're almost out of class time. No, we got. Okay. So let's continue. What was the IP address they listed on that question? Just as he closed it. Sorry. I want to finish answering this one for you.
What, the IP, Dan?
Yeah.
Oh, you want the one with the subnet?
Yeah.
205.61.128.64.
61.1.
28.
Is that right?
Yeah.
Okay. Now, that is the IP address. The thing we haven't talked about yet is what are the valid hosts on that. Remember, we talked about making up into 16 separate little networks. Each network is how big? Each network is 16 in size, 14 usable. Are you okay with that? Remember, look at the number of zeros, 2 to the number of zeros. So each of the networks is 16 in size. Okay? So, let's continue on here. All right? So, what are the range of these networks? So the first one is probably...
205.61.128.0.
Okay. I'm only going to write the last part. I don't know if I'm writing it all. The first one starts at 0. Then, starting at 0, how many is 16 addresses? What's it end at? What's 0 plus 16?
16.
0 is a number. So that throws a lot of people off. Okay. So the range of the first subnet is 0 to 15.
Actually, wouldn't you exclude the zeros being the broadcast?
No, the 0 is the network ID,
Right.
and the 15 is the broadcast.
Oh, okay, so the usable IP address is 1 to 14.
Right. The usable IP address is 1 to 14. Okay. So according to the question, they talk about a computer with this network ID is the way they mentioned it. Okay. So what would an easy way to figure out what the ranges are? Just
Increments of 16.
correct. 16, 32, 48, 48, 64, 80. Are those in increments of 16? They are. And the way you figure out where the end is 1 minus. So this one goes to 31. This one goes to 47. This one goes to 63. This one goes to 79. And so on and so forth. Those are the ranges. So I just wrote the first few ranges out. So, when asked about this IP address, okay, with that network ID, which range is that in? Is it in this one? How about this one?
So that third.
It's in this one. Because 64 is in that one. And it happens, I don't know if they tell you that's a network ID, but they say with an IP address of such and such. The 64 falls in here, okay? So if the 64 is the network ID, what's the broadcast?
79.
79. So if I was to write out what the broadcast is, it's 205.61.128.79. This is the network ID and broadcast. And 16 is the range. Everybody see that? That's the answer, because that's one of the questions on the test. Is D the answer there, Jason? Does that match?
Yeah.
Yeah. Well, the student came to me like, the answer's not in there. I looked, I'm like, I see the answer just fine. I don't know what you're looking at. Yeah. Everybody okay on how to do that? So once, and the way the question's worded, they don't tell you the subnet mask. They make it kind of vague. But what they say is you have 16, you have a class C networks. We already know these are all 255s on the left. So all we're working with is the right-hand part, the last octet. With 16 subnets, well, 16 subnets, that means 2 to the 4th is 16. So obviously it has to be this guy, has to be a 240. And if it's 240, that means I have 4 hosts. That means the range is 16 as well. Okay. So what if I asked you the same question? Let's do this again. We're going to change it this time. Now we're going to use the subnet mask of... Okay, we're going to pick a network up here. I'm not going to do this ahead of time. I'm going to just guess. 67 is the IP. That's just the IP. I want to know the network ID and the broadcast and the range. Okay? 67 is the IP. And I want to have 8 subnets. Okay, so we have a Class C network with 8 subnets. Okay? What I want to know is, based on that information I just gave you, Class C network with 8 subnets.
You have one IP address available. It's
Okay.
at 255 to 55.
Is this 8? 8 subnets. This is it. 2 to the 3rd is 8. Isn't it? Remember I said 8 subnets, not 8 hosts. 8 subnets. So 8 subnets, 2 to the 3rd is 8. So how many hosts do we got? 2 to the 5th. So we have 30 hosts available, don't we?
So increment of 32.
So our range is 32. So if we start, and so we know our range is now 32. So with an IP address of 67, let's get rid of all this. With an IP address of 67, which range does it fall in? What's the first range?
0 to 32. Or 0 to 31. Sorry.
0 to 31. And the second range is 32 to,
63.
should be 63. Yeah. Okay? And the next one starts at 64. It goes to what? 60, 60, 70, 96. So maybe 95. Is that right? That can't be right. That's right. Is that right? Just doesn't look right.
It's 98.
Yeah, that's right. Yeah, these all go down by 32. So what's the network ID in the broadcast if that's an IP address?
Broadcast is 64.64, or a network is .64, broadcast is .95.
Everybody see how we got that? I want to find out where this IP resides. This IP resides right in this range, doesn't it? So the network ID is 64, the broadcast is 95. And the range is 32, and the subnet mask was 224. So we got all that information out just by little questions there? Yes? No? I mean, that's not a question, but it's similar to one we just did. Okay? Now why don't we change it up so it gets more difficult?
Do a class B.
Yeah, exactly. Exactly. How do you know I was going to do that?
Tricky.
Okay, let's change it up a little bit.
You seen that smile?
There's my subnet mask now. Okay, 240.0. So that means okay, so that's my subnet mask in decimal and binary. Everybody with me? The reason I picked 240, when I was in the network shop at Tinker for the last 5-6 years, that's what we had. And since we had to statically assign it to thousands of machines twice, not just once, twice, I got very proficient at that subnet mask. Like, wow. So, how many hosts are there per subnet?
What's a CIT?
12.
8, 9, 10, 11, 12. Very good.
CIT of 20, isn't it?
So yeah, 20. We're going to get there in a second. He talked about the next thing we haven't covered yet. That's right. So it's a CIDR classless interdomain routing of 20. We'll see that in a minute. It gets rid of half the crap we're doing. Which is, I like it when you, like a Netgear router allows you to put that in there. It's like, oh, so much easier. But we're not talking easy. We're talking the tough way. All right, so that's my subnet mask. There it is in binary. Now, how many zeros do we have again?
2 to 12.
We have 12. Okay, so what's 2 to the 12th? Let's ask Handy any calculator here, since I don't know offhand. 2 to the 12th. 4096.
So 4094 hosts.
Yeah, we have a range of 4096. Okay, 4094 usable. So a range equals 4096. Everybody with me so far? Everybody following that logic there so far? How we got that? It was 2 to the 12th. Remember there was 8 zeros there, 4 zeros there, so it's 8 and 9. You add them all up. 9, 10, 11, 12. 2 to the 12th was 4096. Everybody got that? Okay. Everybody got that? Okay. I want to know what the first available IP address is. What's the last? I'm going to give you the first part. Your IP is 66.210.163. Actually, hold on. What I want to know is what is the first IP of the or what does it belong to? How's that? What's the first? This is actually the network ID of the above IP. Okay, this IP address there, 662.10.163.15. We know it's in a group of 4,096 other addresses. What's the first one and what's the last one? Make it a lot tougher, doesn't it? It's exactly the same thing we did a minute ago. And how we do it? Forget about this. Forget about that stuff. Forget about that. Only work here. Okay? Only work on the part that's not all ones or all zeros. How many zeros do you see here?
4.
Okay. 4. Okay, so our range in the third octet is 2 to the 4th, which is 16.
Or 16.
Okay, so the range in here is 16. So basically, it's going to be 66.210.16 all the way to 66.210.31 something. Okay? Is that? Actually, I forgot the first one. Hold on. The first one is 66.210.0 through 66.210.15. That's the first one. The first one starts here and ends here. Isn't this 16? Isn't this 16? Okay? All right? Once, we're going to make this easy. Hold on. Much easier. We'll do a larger one in a minute. So first of all, where does this one fall?
First.
It falls in this. Remember, this is the first. But I didn't quite finish it. Okay. So, the network ID is the first IP address. What is the first IP address?
0.0.0.
0. What's the last one?
.255.
There you go. Wasn't that easy? It's exactly the same thing we did when we did it on the Class C part. Then all we just added was a 0 and 255. What's the first usable in this range? 66.210.0.1. The last usable is 66.210.15.254. And we can use every number in between. Every single address. Jason, you look like you did. Okay. All right, what we did was, remember we did this when it was over here? It was just a second. Do it again, but leave off the ending part. Remember our range was 16 before? So it was 0 to 15, then 16 to 31, and 32 to 47. Remember that? Remember? Well, just don't worry about this. Leave that off. Figure out what your range is, and our range is 16 because we have 4 zeros. In the third octet, we have 4 ones and 4 zeros. So, since we have 4 zeros, 2 to the 4th is 16, so our range is 16. So 0 to 15. Then the first IP is obviously 0, the last one's 255. It's very easy to work out. Okay? Now, let me make it a little bit tougher on you now. Which range does that fall in? What's the network ID, in other words? I could sit here and go 0 to 15, 16 to 31, 32 to 47, 48 to whatever the heck is next, and keep going. But who wants to do that? There's an easier way to do it. The network IDs, can you see anything in common about them? Let me write the next one down. Okay. Do you see anything in common in the network IDs?
Just incremented by the number of hosts.
Well, they're incremented by the range. They're incremented by 16. So if I can divide 163 by 16, and it comes out even, is that not a network ID? Let's try it. It's not going to be. Let's just do it. 163 divided by 16. 10.1. Oh, great. What the heck? But now what I know is I know 16 fits in there 10 times. So 16 times 10 is where it begins. So if I did 16 times 10, whoops, 16 times 10,
You did point.
16 times 10, I get 160. Everybody see that? So I know for a fact that, where's my mouse? Somewhere down the road here, 160, so it'll be 66.210.160. The next one will be that
Plus 16.
plus 32, 16, sorry. So it'll be 176, so this goes all the way through 175.
And then it's .0, not
.0 and .255, exactly. So that's how I found out where that one belongs. I mean, I could have sit there and wrote them all out, but they're all divisible by the range. Every one of them. So divide that sucker by 16, and then round it to an even number, which happened to be 10 in this case. So 16 times 10, and obviously 163 is right in the middle there. Okay? What do you think? Kind of understand this a little bit? Maybe?
I'm thinking we need a Java program to do that for us.
Actually, you know, there's a website out there called learntosubnet.com. It's really good. Go there, walk it. There's about 10 different ways to do this. Learntosubnet.com, excellent website. Can't use it on, well, actually the test you can do at home. So if you're quick enough with the calculator, you'll be okay. But learntosubnet.com is pretty good. The book explains it, but explains it different. Those of you who are going to take the routing class sooner or later, I think, Calvin explains it different. I've just done it this way forever, and it seems to work. Okay.
Professor Stowell does a really good job in the CCNA class.
Yeah.
Does a really good job
It's-
setting up, like, especially if you're going to take the CCNA test.
Right.
There's a way you can draw up a table. And
Right, yeah, that's what Calvin does it. He does it that way,
Yeah.
which is good. I just learned it this way, and I've been doing it this way. Let me see. They're always changing. Yep, that's it. Yep. Yeah, there's all kinds of stuff. How to use it, and you can download the add-on for it. Yeah, it's really good. It helps you. Yes. So learntosubnet.com is good, but so you know it's not difficult. But I can tell you right now, you're going to learn it right now. 6 months from now, you're not going to have a clue. It's one of those things, if you don't use it, you lose it. And I'm using it all the time. There's always something I'm doing with it. But at least,
Ask as how that applies to like forensics, or if you're doing pen testing.
well, you always need to know how big the network is. If I can find out what your subnet mask is, now I at least know how big my target is. And when you take my forensics class and stuff, some of the projects, I tell you, scan a Class C network. And I've literally, you know, I give people the 10.10 network to use, and I say, scan the Class C network starting with such and such.
You can even do a DDoS attack just on that subnet
Right.
itself, and you'll
And-
eventually get that computer and everything
Right.
else. on
But
the
what
subnet.
happens is people don't have a clue what I'm talking about. I talk about a Class C network. We're talking 255.255.255.0. 8 zeros, so 256 computers. Some people don't know what I'm doing. A network that starts with 10 is usually a Class A network. Remember I put that a minute ago, A? So we're talking 16 million computers. So what happens is I get students who don't know what they're doing, and instead of scanning 256 computers for their homework assignment, they scan 16 million. And they're wondering, like, man, this assignment takes forever. And they're turning all this stuff that wasn't, I'm like, dude, that's not even on the right network. And they're like, but you told me 10. I'm like, no, dude, I told you Class C. So I incorporate that in a lot of classes. So I'll tell you, you know, scan a network that begins with this range or this network ID, stuff like that. Now, network ID, subnet ID, same thing. You'll hear them talk two different ways. Network ID, subnet ID, same thing. Okay? Kind of got that? I'm getting low on time here. All right. Now we're on to our first slide. Yes. All right. This is basically what we do. This is subnetting out a Class B network. Okay? And, you know, it's number of subnets to 2. Well, actually, this is wrong. Right. This is the part that is wrong. Because this, remember I just told you a minute ago, that's 8. You don't really have to subtract the 2 on the subnet. You got to subtract the 2 on the host. So this is really 16. That's really 32, 64. Yeah, it's off a little. And there's also, I think it's on the next one. Yeah, you don't see anything wrong with these addresses right there?
2 is 2 is not 2.
Well, they're all missing a 0 at the end.
Not bad.
They chopped the 0 off. Because there should be 8, shouldn't there be? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. They chopped the 0 off.
Somebody got fired.
Yeah, so the book has an issue in this area. Okay. So for number of networks, number of subnets, don't subtract the 2. Only do it on the hosts. Because the student who came to me for help today, she's like, But it says I got to subtract the 2 and the network. So I'm like, no, it don't. Where'd you read that? Sure enough, it's in your book.
But it doesn't say it, it just illustrates it.
Yeah, well, yeah, no, it's not right. It's one of those deals, I'm working on my PhD. Everything I use has to be referee journals, which means someone wrote it, sent it out to all these industry experts. They made all the comments that came back. He fixed it all. Send it out again. There was no names. It was all anonymous. So this is like 3 times. By the time the final product comes in, these zeros would have been fixed. This textbook, it got edited by someone with a degree in English. When I taught wireless the first time, someone went through the PowerPoint, removed all periods. Try teaching like 802.11 was 802.11, and all the IP addresses were all run together. Someone just went through PowerPoint because in a PowerPoint you're really not supposed to put a period at the end of your sentence. They removed all periods in the whole presentation. I'm like, what the hell? The problem is they're edited by an editor that's not a computer scientist. They do a decent job. They're just not perfect. So just take the book with a grain of salt. They don't cover everything, but it's close. Okay. Now, here's how to start calculating it. It's 2 to the n minus 2. Okay? But that's really only for the hosts. 2 to the n is the number of subnets. 2 to the n minus 2 is the number of hosts. That's what we talked about. So this is kind of an error. Because the problem is, if you go by this formula, you'll match the book. But it won't match the answers at the end of the chapter. Because the answers at the end of the chapter do it correctly. So what happens is, somebody else writes the end of chapter exercises. And someone who knew what they were doing was doing it. Because if you go by the book, you're going to be wrong.
So are the answers to the end of the chapter in the book?
No. But they're close. Just remember, don't subtract 2 when calculating subnets and you get that part right.
No, I mean, but if we go to answer...
Oh, the correct answer is in there.
Oh, okay.
Yeah. It's just that if you try to do it the way they tell you, you're going to come up with an answer that's not in there. That could be why Tracy, who came and saw me, couldn't get the answer. I don't know, but I'm like, well, who told you that? She goes, it's in the book. I'm like, oh.
At least you know she's reading the book.
Exactly. Yeah, she's quite anal about it. Anyone knows Tracy. Man, she'll read every word. Which is good. I'm glad she does. She gets upset when she gets like a 97 on something. Oh my God, the world's going to explode. But I like people. She doesn't know this stuff. She's no computer background at all. She goes, this is my only experience, which is good. I'm glad. She's the one who's watching all my recordings and everything. So, all right. So, kind of with me? All right. They talk about the different subnet numbers. This is where I was talking about the range. From this address to this address. See, from that to that, from that to that. And you notice the usable, is the one. So basically, you're missing one for the broadcast. So this one started at 32. The next one starts at 64. So the first one's broadcast was 63. Okay? The network ID was 32, but the first usable was 32. Or 33. It's just what I said. They just do it in a very weird table here. Okay? They went like 4 or 5 years without updating this book. Now all of a sudden they're updating it every year. What the heck? So this wasn't messed up a couple versions ago. I haven't looked in the 6. It might be okay. Okay. So we have A, B, C networks. Can be subnetted. We can break the C into pieces, the B into B. We can do the same thing with A. Okay. That's what happens. Like Cox, my IP address at my house starts with 66. That's from Cox. Okay. That's a Class A network. So they actually subnetted a Class A network out. So 66 through, I think, 68 belongs to Cox. Okay. The LAN subnetting says devices interpret devices subnetting information. Internally, we can determine what each other's subnet is. But externally, we can't. We just go by the IP address. So that's a little different. And it really goes to the router. Really waits to get, so it's not that critical. But internally, we need to know that. Okay. All right. And they're showing us a router is connecting several subnets. Okay. All right. So let's see what we can figure out. There's the 32 subnet, the 64, the 96, the 128, and the 160, and then the 192. Then each one can have their own in there. And you can have a router with multiple interfaces on it. Normally they're a lot more expensive, but we're never going to finish this chapter. Okay. No, okay. So about CIDR. This is what Daniel mentioned a few minutes ago. Back on my little chart here. Okay. So if I was writing this subnet mask right here, if I was going to write out that subnet mask right there, I could write out 255.240.0. I could do that. Or I could write 860, I could write /20 instead.
In front of the IP address.
Right. What you would do, if my IP address was, let's pick one. Where's this one? So that was my IP address. A lot of times you see it written like this: IP address and subnet mask. Or like that. You get rid of the subnet mask. Okay? Isn't it the same thing? CIDR, classless interdomain routing, basically says how many ones are there? Because aren't we only worried about what's the whole subnet all about? Number of ones. Because remember we determined number of ones and number of zeros. The ones are the network, the zeros are the hosts. And since they're all contiguous, if we figure out the number of ones, don't we just know the number of zeros? So if I told you there was 12 ones, how many zeros are there? 12 ones. 12 ones.
36.
It's 32 total. 20. No, is that right? 8, 16, no, it's 30, yeah, it's 32. So if there's 12, there'll be 20. Okay? I was backwards there. Okay. But, so if all we really care about nowadays, see, way back at the beginning of the internet, we went with A, B, and C networks. No one really cared about this subnet mask. Because, oh, if you had a 10, you're an A. But even here at Rose State, we have a 10, we use it as a B. At home, I have an A, we use it as a C. You know, let's look at this router I got open here. Okay? This is a 98. Okay? This is actually a very good example here. 98. Is that A, B, C, or D? It's an A. An A should have a subnet mask of 255.0.0.0. Is that correct? I'm not thinking so. I don't think that's 255.0.0.0. So what they did was they took that class A and broke it into smaller pieces. And their subnet mask is 255.255.255.40 or 240. So how many computers or how many IP addresses does this router have? So what's 240 in binary?
30.
What's 240 in binary?
14.
14 usable. It's 1111.0.0.0.0. So it's four zeros. That's 240. Okay? 4 zeros is 16. 2 to the 4th is 16. 14 usable. So what that means is this guy right here, this computer. Actually, let's go through that whole thing. Let's write this one down and do it. It's a good example. Okay, they have 98.174.173.147. 255.255.255.240. Okay, what we need to know is the net ID, the range, broadcast. Okay? So, did we already figure out what the range was? Since we have 240 for a subnet mask, we already determined 240 was 1111.0.0.0.0. So the range is 16. Okay. So the range is 16.
Might want to raise that up a little bit.
Oops. Or zoom out just a little right now, since I don't need it so huge right now. Okay, range is 16. So, since we're worried about this last IP, this last octet right here, is that a network ID? I don't know. How can we figure out that is?
Divided by 16.
I can divide it by 16. So 147 divided by 16. No, it's not. So why don't I go 9 times 16? So 9 times 16, 144. So the network ID is 98.174.1. 173.144. Thank you. What's the last one? So do plus 16. So the last one is 159. So it's 98.174. Oh, I can't type it. 23.159. All right. Everybody with me how I did that? So I didn't get their service for them or anything, but just looking at what I got from their router, now I know that they're paying for 16 addresses. 14 usable. They still do charge you for 16 though. It sucks. Yeah. But that ISP, we actually advertised it as 8 usable IPs, which is that's why they got beat. Yeah. Yeah, because nowadays they should tell you the range of 16, but there's 14 usable. Okay. So the first one's 144. The last one's 159. So this one's kind of in the middle, 147. So could I change that? Sure I could. It would still function just fine because it's in the right range. Now what gets me though, this is St. Philip Neri School right up the street up here. Why the heck they got 16 addresses? You know, this is how companies make money. I'll tell you right now. How many addresses do you think they really needed? 1. Yeah. I can't think of any other reason why they need another than 1. But what happens is they'll call you. Actually, there's a really good article in the news today about them catching people that were calling people and ripping them off over the phone. I'll tell you in a minute. But they'll call you and say, well, how many computers you got? Oh, we're at school. We got 150 computers. Oh, wow. You probably need 10, 15 addresses. That's what they do. They try to say, oh, you need a couple addresses. You need quite a bit. But in theory, you need 1. Rose State, for the entire wired network, uses 1. For the entire wireless, uses 1. So it's kind of...
It's kind of like what you were saying about having to send in the iPad to get fixed or fixing it yourself.
Exactly. We spent $42, including the new Wi-Fi antenna and everything. They would have charged me... Apple was $249 or something. It's crap. But, you know, I didn't even realize they had that, to tell you the truth. I just now noticed it. I didn't even... Wow.
But they wouldn't need it because they can subnet it within their own network, right?
Right. Yes, they can. Yeah, inside their network, it is Subnet. They're got a Class C network internal.
Yeah.
So, and the funny thing is, they got their gateways set up to 145. So I don't. The gateway is normally the last usable IP, or the first usable IP. It's one or the other usually. This one's set up at 145. So I didn't set this up. I don't know who did. It's like, why is it 145? That's kind of like randomly in the... Actually, 145 is the first usable.
Yeah.
Okay, so that's right. Because normally it's the first or the last. But then what is 146? So this is one... If the gateway is 145, and this is 147, what's 146? I don't know. We'd have to see. Yeah. All right, I think we're about done for today. What this means is next week I'm going to finish this chapter, and we'll have a test review probably Thursday or so. Then we'll have a test. Sound good? So the test. Let me stop this. We need to pick up on talk a little bit more on 21.